right, let's get started. Hi, everybody. Welcome to Keep It Secret, Keep It Safe, where I'm going to talk to you about protecting the network traffic in your application. So first of all, basic introductions. I'm Chad Brubaker. I'm a software engineer on the Android security team for about 2 years now full time, and I was an intern before that. There's a picture of me if you want. I'll never show that again. OK, so what am I going to talk to you about? So first of all, the very, very high level, like what is TLS and why you should use it for all your traffic, period, everywhere. Then I'm going to talk about what you actually have to do to use it on the client, and the harder part of actually checking your work, making sure that you're using it. And then finally, we're going to get to my personal favorite part about various mistakes and misconfigurations we've seen, why they happen, why you shouldn't do them, what you should do instead, and finally, some time for questions and answers. So, all right, so TLS. First of all, why? So why should you even care about making sure your network traffic is secure? Well, simple answer is the network is not to be trusted. And this has always been true in computing. Like, this is not new in any way. But for mobile devices, it's actually especially true. Because think of your smartphone. How many different networks does it connect to in a given day? Different Wi-Fi networks, different cellular networks. And setting up a Wi-Fi network takes basically zero effort, right? I can go down to a coffee shop, make an open Wi-Fi called, super awesome, fast coffee shop Wi-Fi, and people will probably connect to it. So it's very easy for this to happen to smartphones, to be on a network that may be hostile to you. And finally, like, smartphones are very personal devices for all of us, right? They contain a lot of your personal information. You use them to transmit a lot of personal information. You do banking, you do all these kinds of things. So it's important. Now, when you think of like sensitive traffic that needs to be protected, there's a couple sort of canonical examples that come to your mind that kind of get talked about in articles and stuff about like obviously sensitive traffic that you think, oh yeah, I definitely don't want a random person messing with it, seeing it. It's like very basic examples, right? Like I shouldn't be able to see the login for your banking account, right? You probably don't want that. Likewise, I shouldn't be able to see your credit cards. If you're sending private photos, shouldn't be able to see that. And not only just kind of eavesdropping, but also modifications. So you wouldn't want someone to say replace the email to your boss saying like, yeah, I can totally do that thing you asked me to do, and just modify that to be like, no, I hate you, I quit, right? Don't want that. That would obviously be bad. Sensitive web traffic, health. These are sort of all the examples that kind of come to mind when you think like, what is traffic off my device that needs to be secure? OK, but what if you don't do that? So thought experiment that I always hear is a food blog. So I run Chad's stupid food blog full of really bad advice about food. Should I still secure my traffic? It's about food. No one cares. It's not sensitive. Yes, you should still secure your traffic. Oops. For two reasons. First of all, it's 2015. Just do it. And second, it's 2015. I'm done. Secondly, even if the content isn't directly sensitive, that doesn't mean you can't do any bad things with it as an attacker. So the first and sort of most, nuclear approach is even like completely harmless content. Say I have an exploit for your browser, and I'm a bad guy. Even if the only HTTP page you go to is my crappy food blog, I can go, modify the traffic, inject that exploit, and that's my route to get on your device. Sort of more in general, kind of modifying content in subtle ways. For the food blog, this probably doesn't matter. Change my really awful recipe to maybe less awful. But like say your Wikipedia, like slight tweaks to history, these kinds of things. And sort of on that front, what actually impacts developers a lot is replacing things like ads. So you have all these costs for running your servers, your backends, bandwidth, and you offset that through ads. OK, sounds good. That's how the internet works. But if I go in and I replace those ads with ads that pay me, right, that's bad. You're now eating all the costs, and someone else is actually getting the money. That kind of thing. And finally, tracking and snooping, right? If I'm the only person in the world that goes to my food blog, which is likely true, then simply seeing that, oh, this phone connected to this food blog means like I know that phone is Chad. So that's not good. And sort of the overall goal in general is that the network cannot affect the security of your device or your data in any way. The network can always block traffic and always refuse to do things for you, but it shouldn't be able to hurt your security in any reasonable way. And this is what TLS is for. So TLS, this transport layer security, is previously known as SSL. So if you hear these two, they're sort of they're used kind of interchangeably. So the way it worked was you had SSL v1, v2, v3, TLS 1.0, TLS 1.1, TLS 1.2. So It's used interchangeably. I'll probably even say SSL a bunch, same thing. And it's used with any protocol. It wraps whatever you want. So HTTPS is HTTP over TLS. SMTP and IMAP have start TLS, all these kinds of things. It's completely generic to the protocol. You can use it for whatever you want. And it gives you an end-to-end secure channel between two peers. And you get two very important things from that channel. You get integrity, so you know if anyone goes and messes with the data in that connection, you know about it, so you can basically throw your hands in the air and say, I'm out. And confidentiality, so only those two peers actually see the data that's being transmitted. Now, the hard part is often making sure that the peer that you're connecting to is the peer you meant to connect to. And we'll actually talk about that later in more detail when I get to the pitfalls and mistakes. But the good news there is that generally on all modern platforms, it's safe by default. So you just use it. That whole peer complexity is kind of handled for you. Life is pretty good. So using TLS, this is actually the shortest part of this whole talk. So if you're using HTTP, it is actually just as simple as rewriting the URL to HTTPS, and it just works. The same standard libraries you use just keep working. If you're using URL connection, it's just a simple letter replace. And generally for most HTTP clients, it's the same. It's just completely transparent. Now, if you're implementing your own custom protocol, it's still easy, but a little harder. So you can use, if you just use Java sockets, you can basically just wrap it with, just use an SSL socket instead. There is one very, very big pitfall, though, that you need to keep in mind, is that unlike what the HTTP clients do, SSL socket does not check that the host that you're connecting to is the host you expect it to connect to. And this is something really important. If you don't do it, your connections are completely insecure. And I'll talk about more when I get to the mistakes. So here's some sample code. The important bit is this hostname verifier.verify to check that we actually connected to android.com and not, say, evil.com. So on the server, now this is probably the hard part for a lot of you, and unfortunately I'm going to basically skip over it because I have 45 minutes, and this is a really big subject. So if you're setting it up on your own server, SSL Labs has a really good best practice for deployment document. I highly recommend you read it. And generally, if you're just using some cloud service for your backend, everybody has pretty good TLS support nowadays. So use it. So OK, so let's say you decide, OK, I really want to use it. I've gone through, and I think I've replaced all of those HTTP URLs with HTTPS. But how do I know that everything that I'm sending is over a TLS connection? Like, how can you be sure? It's always important to test, especially with security code. You want to make sure you're actually doing it right. And so why do you have to do this? So let's consider the most obvious case of source code, right? I open just a static, httpsexample.com, and I go there. Is this over HTTPS? Yes, but it's actually more complicated than you'd think. Because what if that page immediately says, actually, the content is over here on httpexample.com? So for the HTTP URL connection in Android, it actually explicitly does not follow those redirects. But if you're using a custom client, that might not be the case. And it's actually a little tricky. But that's not how you usually use URLs. What you'll often have is that you'll get them from your server backend. So consider you have a bunch of contacts that your server pushes down. And one of those things is a profile picture. Your data is basically going to be like name, Chad, profile picture. Here's a PNG on the internet somewhere. And you're just going to blindly open that URL. And this works great on Android, like whether it's HTTP or HTTP, your code just works. But what happens if, today when you ship your app, it's HTTPS, but then 6 months down the line, you're doing some tweaks on the back end, and you accidentally set those to HTTP, and you don't realize. Like, suddenly, all those security guarantees you were trying to get are kind of out the window. And finally, what about the third-party code in your application, right? You don't want any of your traffic to go out over non-secure connections. But what about that ad or analytics library you downloaded? Do they? Do they respect that? How do you know? I don't know. So what do? So in Marshmallow, we added a couple of features to help you both in development time and actually released on devices. So the first thing we have is some new strict mode detection for clear text traffic. So while you're developing, you can detect stuff. And also a manifest flag that lets you specify whether or not you plan to use clear text. And these are not just for HTTP, HTTPS. This is for anything. So first of all, the strict mode support. So the goal of this is, while you're developing, and use your standard strict mode stuff to detect clear text traffic, notify you, crash the app, whatever. That way, as you're developing, you can find these issues. And the way the strict mode detection works is it actually does packet inspection of every single connection that leaves your UID for your application. And it checks to make sure that the very first thing it sends is a TLS client hello, basically the start of that secure handshake. And that's good because it means that no matter what your code is, it's native, it's doing some weird custom written stuff, it will detect absolutely all of it. The downside, though, is that there are some false positive issues because not everything that uses TLS starts immediately with that client hello. Even the most basic example, if you use an HTTP proxy to send HTTPS, still secure, but the very first thing you'll send is actually sort of the connect message. And likewise, if you have protocols like XMPP or IMAP, those actually do a little bit of handshaking before they say, OK, now let's switch to TLS. And those will all get, unfortunately, detected by this. But this will let you, at least if you're doing just HTTPS, HTTP, this will let you check at development time pretty easily. And that's great. So the next side of things is, OK, you've shipped your app, but how do you protect against kind of accidental regressions, right? Like the example I had where your back end 6 months down the line starts pushing HTTP URLs instead of HTTPS. Sorry. So for that, we added a manifest flag called uses clear text traffic. And what this is for you to basically say to the system, I do not intend to do any clear text traffic. So if I do, please stop me. And this is completely best effort, so it's up to libraries to support this. As far as libraries that support it right now, all of your HTTP URL connection, OKHTTP, the Apache HTTP client, all of these support it. Download Manager, Media Player, things you do through that. Unfortunately, not supported as WebView. But if you're using those standard libraries, you set that flag, and if 6 months down the line you accidentally do that URL change, those apps, those connections will fail. They'll throw an exception, hard fail. You don't send any traffic out over the network in the clear where someone could do bad things with it. So the question I get quite a lot is, why do you block traffic instead of doing sort of transparent upgrading? And there's a couple reasons for this. So first of all, if you do transparent upgrading, all of your older devices are basically just kind of left out. They're completely out of luck. If you only develop on a newer device, you might not even know that you're actually doing these connections over HTTP. You just see them ending up going out securely. And finally, upgrade logic is actually not, it's a big pain. So first of all, for non-HTTP, it might not be obvious what the sort of upgrade path is. It might actually require, this protocol is just completely not allowed. And also, just doing the standard rewriting of HTTP to HTTPS might break your connections. There's still a lot of websites out there right now where if you connect them over HTTPS, the connection works, but the certificate you get is for some random CDN or just some complete noise. So instead, by blocking, you'll know immediately, and you'll actually be able to see, oh, OK, I'm you'll get the crash notification. You'll see, oh, crap, this is now over HTTP. You can fix it, and you can fix all the devices, not just devices running M and newer, but absolutely every device. And that's a lot better. So, sorry, some water real quick. So now my favorite part, because I'm a security person, are the various mistakes and misconfigurations that people make. So how do you know that you're using TLS correctly? Well, the good news is it's secure by default on basically all modern platforms. So if you don't try and do anything custom, you are good to go. Life is great. You don't need to do anything. Unfortunately, it's possible to override a lot of these defaults. And you'd like to hope that no one overrides these with insecure code, that it's always secure code that's well thought out. But that's really not often the case. And so throughout this whole thing, I'm going to be referencing a lot of information that's also available on the Security SSL training article. It has code samples for all this. It has a lot more words that I'm going to go into. And I highly recommend you read that. If you're ever doing TLS stuff, please look at that first, because it's a better source than most of the internet. So why do people put insecure TLS code into their app? Well, the simple answer is that what happens is someone has an issue. They go on a forum. They post, hey, I have this issue. Someone hands them a code sample that says, yeah, just take this. This will fix your problem. Copy and paste it into the app or run it. Good, ship it. The problem is that most of the code samples provided are bad. They fix the problem by basically removing all of the security. So you'll never see that security exception again because you'll never see a security exception. And that's not what you want. So before I kind of go into these, I'm going to go into slightly more detail about what checking trust in TLS actually is. I'm going to skip over most of it because it's really in depth, and I don't think you need to know most of it for the context of this. If you want to, you can go read an RFC. Have fun with that. So there's two big parts about TLS trust checking at a very high level. First of all, that the person you're talking to is the person you intended to talk to, and that they have a trusted certificate saying they're that person. And these are slightly different. So for example, like I can go and I register evil.com. I can go buy a certificate for that because I own it, and that's all fine. But that doesn't mean that my certificate for evil.com makes me trusted for android.com, right? I'm only trusted for that. And likewise, like anyone can make a certificate for android.com and say, yes, hello, I am android.com, please trust me. But you actually need to make sure that it is trusted. And both of these two high-level things, there's a lot of bad code out there on the internet that breaks these. So the first one I'm going to talk about is making sure you're talking to the person you expect to talk to. So, because obviously, if you make a secure connection to evil.com, that's probably not what you wanted when you wanted to make a secure connection to android.com to send, whatever user secrets or magic you wanted to send. And now, this is done for you by standard in all the HTTP libraries. Again, if you're using SSL socket, it's not. You have to do this yourself. If you're not, you have a very big problem. So the problem that gets a lot of people to take code off the internet is dealing with legacy clients or legacy servers can be kind of tricky. So say you have a server, and on that server you host a bunch of different domains, like most servers do. You have example.com, example.org, and say even android.com. And each of these has a completely different certificate. And when you connect, so you connect, and the client says, hi, I want to talk TLS. Please give me your certificate. Which one do you provide, right? You've got 3 possibilities. You need to provide one. Which do you do? So the good news is that this problem was solved a while ago in TLS with what's called the server name identifier, which basically says in the client, hello, hi, I want to talk TLS, and by the way, I want to talk to example.com. But you might not always have that. So for example, if you're dealing with really old clients, you might not get that. Or also if you're using an older protocol like SSL v3, which doesn't support such things. So how do you make sure that those connections still work? So the right way to do this is a little complicated, but you basically need to check that, OK, I know that the default for this server is actually going to give me example.com. So when I connect to example.org, I'll actually explicitly check that I got a certificate for example.com. Now, it's important to say that you probably don't need to do this. SNI has been supported on Android since 2.3. So if you don't support back that far, don't worry about it. There is an asterisk around that, which is that the way that a lot of HTTP clients work is they'll try to connect with sort of like the most modern TLS settings. And that may fail because, unfortunately, on the internet, there's just a lot of old kind of bad networking hardware that chokes on TLS. And so they'll do sort of a protocol downgrade. And that can lead to you downgrading to SSL v3 on some libraries. And then at that point, you no longer have the subject name field, so you might get the wrong certificate. But usually, if that happens, SSL v3 will fail as well, because you're just on a bad network. So the wrong way to do this, some very common advice out there, is you replace the default hostname verifier with this hostname verifier that always returns true. So is evil.com trusted for this connection to Android? Yes. This is kind of like obviously bad code. Please don't ever use this. Like, it's very easy to man the middle. I go buy a certificate for evil.com. In your connection to android.com, I just hand you that certificate. You say, oh, yeah, this is trusted. So it was issued for evil.com. Connect. So this means that you will connect to basically any valid certificate. And anyone out there can go buy a valid certificate for their own domain. It's 20 bucks. Nowadays, you can probably also just get them for free. So even if you have a valid certificate, it's not just valid everywhere. It's valid for one specific thing, and you really need to make sure that's the case. So the next thing is actually how do you make sure that the certificate that you got is trusted? Like, what does that mean? So again, this is going to be very high level. I'm not going to go into it in a whole lot of detail because it's very complicated. There's RFCs the size of my arm you can read if you want to know the full detail. But this is going to be just a very high level overview. So when I say, like, how do you verify the peer? So what is the peer in TLS? It's usually represented by sort of their certificate that they provide. So you have some options for, like, how do you trust this? You could always hard code it. But that doesn't really work because certificates change, and they change very often. For example, Google.com certificate rotates every 3 months. So you can't just say, like, in your application, I expect the certificate to be this, because in 3 months, it's going to be completely different. And generally, that doesn't scale. Like, what if you're an application that, you're like an RSS feed reader and you just connect out to the internet. You obviously can't hard code the certificate of every web page on the internet in your application. I hope. Don't try. So what is a certificate? It includes the name, so who is this for? Includes the public key for the asymmetric crypto, which you don't have to worry about for this talk, but crypto keys are in there. And it contains an issuer, and this is someone that's basically said, I am stating that that cryptographic key up there is tied to google.com. So this would be like VeriSign or GeoTrust or certificate authorities you've heard about. And it contains a bunch of other things, expiration dates, key usage, et cetera, but we'll skip over those. So the issuer itself is also a certificate. So this google.com certificate is issued by VeriSign. That VeriSign certificate is probably issued by another VeriSign. And you get this chain. So you have this nice chain, but like, how do I know if I trust this chain? Sort of like you keep building this, but it's turtles all the way down, if you've heard the expression, which hopefully you have. In the end, you still need to say, like, do I trust this long chain of certificates? And the way you handle it is, your operating system or your application ships with a set of trusted certificates. And so these are sort of your very top level roots. And then you get a chain from your server, and your server says, I'm google.com, and I'm like, I don't know that certificate, but I was issued by VeriSign. And so, you do the lookup, and you say, oh, OK, I actually do trust that VeriSign certificate. It shipped with my application. It shipped with the phone. So another question that comes up pretty often, so I'm going to kind of detour into that for a second, is how can you trust the CAs on the device? Like you look, and there's 100 or so, and you don't know who most of them are. Like, how do you trust them? This is sort of a hot topic. So there's sort of two things to keep in mind when you're asking yourself, how do I trust these guys? Why can I trust these guys? First of all, they do have a lot of strict requirements. There's audits, et cetera, just to get in sort of general certificate authority lists. Not just for Android, but sort of this is the standard in the world. And finally, like, not only is it hard to get in, but there's actually a lot of work to verify that no one's doing anything bad. So you have things like certificate transparency, where you actually note down like what certificates have you issued, or things like pinning, so that you can actually detect if anywhere in the world someone misissues a certificate, even if it's only used once. And that lets you detect misuse. And then from there, there's risks to business, all that fun stuff. So OK, back to trust checking. So the problem is what if you want to trust your own certificate that the system doesn't normally trust? And this can be for a couple of reasons. Maybe you want to use your own certificate just for local debugging. Right? You don't want to take the certificate for your actual backend and put it on your random developer workstation. That's probably not a good idea. That just doesn't feel right. And secondly, you might actually just not trust certificate authorities. Like, sure, I made a very quick argument about why they're a pretty reasonable source of trust, but maybe you don't want to, and that's fine. So maybe you want to run your own certificate authority and ship that with your app and only trust that. Or maybe you have some internal network, and you issue certificates for internal web pages using that, and that's obviously not trusted by the device by default, so you need to sort of ship it with your app and make sure that your stuff can connect. So I'm not even going to include the code for the right way to do this, because it would take 4 slides when I tried. It's pretty verbose, but you can go get it off that security SSL training article I told you about. It's not complicated. It's very verbose Java, so I'm going to save you from that. But the real gist of it is you basically take the certificates you want to use, and you tell the system, OK, these are the trusted routes for this connection. Connect as normal. And that all works. But unfortunately, the code that you usually find on the internet when you search for that exact problem is this. And this code isn't the clearest, so it's going to require a little bit of explanation, because it's very verbose. So we make an SSL context, not important. We make a new X509 trust manager. And it has these 3 methods: check client trusted, check server trusted, and get accepted issuers. And then we set this as the default socket factory, so it's used for all connections. So what does this actually do? So we have this blank check server trusted method. What does that mean? Well, if you go and you actually look at the real documentation, and you read, check server trusted throws a certificate exception if the certificate chain can't be validated or isn't trusted. OK, so that line is completely empty, so it will never throw that certificate exception. It will always be trusted no matter what garbage you give it. And that's bad, because that means that absolutely any certificate in the world is trusted. And it's completely trivial to make a certificate, right? It's just a bag of bytes, run it through OpenSSL, done. Again, do not ever use this code. Now, I have seen this in actual production apps, but also a lot of apps tend to use this code for debugging. Sort of you have this if debug, install that, check. And that's OK so long as you never actually ship it. And unfortunately, that happens sometimes. So the better safe thing to do is just don't use code that disables the verification completely. That is way too big of a hammer and way too dangerous. For local debugging, what you should do is, again, back to this code that I actually skipped, is have a CA that you use only for debugging. On your debug builds, put that in your app. Trust that certificate. Do not turn off trust checking. All right, if you accidentally ship that, suddenly all your users are now easy to attack, and that's not what you want to do. OK, so sort of lessons for you. If you're not overriding the secure defaults, there's nothing for you to worry about, right? You're good to go. Life is great. But if you are, some important takeaways. First of all, make sure you actually need to, right? So the hostname verification example at the start, I've actually met with some developers who said they needed to do it for making sure they had SNI working on devices that didn't support it, which was odd because the earliest version they supported was Jelly Bean, which already had this, right? So before you even go customizing it, please be sure that you actually need to, because this is sort of like the most dangerous way to do things. Secondly, once you've decided that, yes, OK, I need to do something custom, Chad, I'm going to do it, please don't blindly take code samples off random pages on the internet without understanding them, right? Especially for security-sensitive code. Unfortunately, there's a lot of really bad code out there for this, because what happens is someone says, hey, I can't connect to my server, I get the certificate exception. And the advice is straight up just, oh, use this code, and you won't get the certificate exception anymore, which is technically correct, because you can never get the certificate exception if you use that code. But that's probably not what you really wanted. You wanted to fix the issue with that single connection. You probably are using TLS because you care, right? So please, don't copy and paste that code without understanding it. And for most of your common SSL issues that you run into, there's actually better documentation on that security and SSL training page on developer.android.com. So really, go there first, not second or last, before random forums, random people giving you code on the internet. So OK, so that's what you should do. So what are we doing about this? Because those bugs are kind of embarrassing, and they're sad. So there's a couple different things that sort of we're doing on the Android side. So first of all, along with many other things, we're doing detection of vulnerable applications in play and actually notifying developers and telling them to fix it. Not just for these bugs, but for actually a whole slew of security issues. Next up, this is what I spend a lot of time doing, is actually tools to find these issues in applications and in generic devices. There was, unfortunately, a complete lack of tools to do this when I started, so I built one. And finally, investigating APIs that make it harder to do things wrong. A general rule for security APIs, and if you ever design anything security, keep this in mind, it should always be easy to do the secure thing and really hard or impossible to do the insecure thing, right? Over-customization is actually your enemy here. So looking at things on that to move away from these APIs that are really easy to get wrong. The trust management code is way too easy to break. So some notes on that vulnerability alert and blocking. So if we detect a vulnerability in your application for SSL, old libraries, those kinds of things, you'll get a vulnerability alert via the email on your console, and you'll get a notification on that page. Make sure you actually go and check these and fix them, because if you don't fix them, your application may be blocked, right? Don't ship things with security issues. And if once you go, you fix it, you upload it to Play, you'll basically get an answer back pretty quickly. And already, a lot of vulnerable applications, a lot of installs have been fixed. So for all of you that have fixed things, thank you. Please keep doing it. We really appreciate it. So finally, on the tool side of things, actually a year ago now, I released a tool called NoGoToFail, which is a network testing tool for finding these classes of bugs and a whole lot of ones I didn't mention in this talk. Basically, all of your SSL issues, not using it wrong in many, many ways. It's on GitHub, Google.com, GitHub, Google, NoGoToFail. And it runs on the network level. So it actually supports absolutely any device. It's not an Android-specific thing. I've used it to test random off-the-shelf things just for fun. And it means that you don't have to change the device in any way. You just plug it in. And it actually works without making your device unusable. So my tablet at home has been on NoGoToFail for well over a year. My personal phone probably spends about half the time on a network running it. And completely usable. I can still read random messages and get cat pictures at 2 in the morning. It all still just works. But a nice thing it does support is if you do kind of have the ability to run code on the client, there's actually this extra thing of client attribution notification. Because what happens when you're looking at network traffic is you say, OK, I saw this vulnerable connection to example.com. I have no idea what on the phone made that, right? Because you don't want to just be stuck with someone on the phone made that connection. You want to say, like, this app at this time made this vulnerable connection. So we have support for that. And what you can actually see up here is an example of those notifications where, so the test app, I basically hit the button to like connect, and you immediately get this notification, MIDM via SSL certificate for another host name, which was the first misconfiguration I talked about, in a connection from the no-go-to-fail tester app to IP port, blah, 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 blah. So it is an awesome tool. I recommend you play with it. But it does require some advanced setup because it does do things at the network level. So it's more targeted toward sort of people interested in security. But if you are interested, highly recommend it. It's probably, I wrote it, but I'm going to say it's the best tool out there for this kind of thing. And I'm pretty sure I'm right. Famous last words on camera there. So play with it if you'd like. And with that, I've got some time for questions and for me to drink some water. So there's people running around with microphones. So if you have questions, I guess stand up is what they told me to tell you.
Hi.
Hi, how's it going?
I was curious, if a user decides to add to the device's trust store with a custom root or custom certificate,
Yep.
Does that make my app more vulnerable?
It depends on the certificate, right? I mean, I suppose if they added a certificate that anyone in the world knew, yes.
Yeah.
Generally, I would say no, because what that tends to be used for is sort of like I have a corporate internal cert, so I add that. Or I have, I'm doing some local testing, I add a MIDM CA to the device-wide. So generally, no. I mean, it's technically possible, but generally, no.
Is there a way for my app to decline all like custom and only use the trusted store that comes with the device?
Yeah, so already like you can specify the custom set of trusted certificates, like I mentioned earlier. You can easily just only trust the ones from the system if that's what you'd like to do. You should be very careful doing that though, because if you do that, there's a good chance that your device might not connect again. Say for example, they added that testing cert that they're MIDMing all the connections with to do debugging and similar. If you don't trust that CA, that basically means that device, your app's never going to succeed in a connection again. So it's a trade-off you have to keep in mind. Some people have made that trade-off for security reasons, but just keep that in mind. Yes?
All right. So through the years, the web view has been made as a component that you can update independently of the framework.
Mm-hmm.
And I'm wondering if there's any plans of doing the same thing, possibly with the boring SSL or essentially whatever SSL library is being used.
So actually, that already exists. Through Play Services, there's what's called a provider installer, which actually does install the most up-to-date version of Conscript, which is the library that does all the SSL on Android. So it's actually already there. It's called Provider Installer. I believe it's linked on the SSL training document as well. And it's exactly what you asked for. Yeah.
My question was a little related to the question he asked a bit ago about the user-installed certificates, and I was wondering if Android's doing anything to really warn users more about that. Like, so one case I think of is Lenovo. They shipped with these bad root certificates, and then I also think about like you go to a coffee shop where somebody's created an open network and they've got like Charles running on their laptop, and they force you to install their certificate to connect.
So a couple things. So there is already notification if you install a certificate. In fact, there's a very scary warning that says like your network traffic may be monitored. We basically have no guarantees for you at this point, because that's true. For the Lenovo case, that's a little different because it wasn't user added. It shipped with sort of the trusted set. For that, we have CTS tests to sort of make sure we don't have similar issues like that on Android. For the final thing of you connect to a network, yes, if you trick the user or you kind of con them into installing a cert, that would be bad. There is a lot of scary wording already around that, so I don't know how realistic that is of actually convincing someone like, please install my Charles CA, but that would be bad. So we have one here, and then one in the back as well.
Hi.
Hi.
I just had a question about certificate pinning.
Yep.
What is your opinion about it? As with the other examples that you showed, there's a lot of bad examples about certificate pinning, and there's also a couple of libraries that are actually doing it. And in the official docs, at least, there's nothing specific about it. So, I just wanna hear your opinion.
Yes, so there is, there's no current any public API to do it. As far as certificate pinning, it's useful in general. What certificate pinning is, for those of you who don't know, is you basically say, I expect this certificate to show up somewhere in the chain, so that it's not just that it was trusted by any CA on the device, but you can actually say, like, you know, it had to come from VeriSign, or it had to come from whoever. Now, there is some danger there that you need to be careful of is if your app has pinning code and you suddenly need to change a certificate, you may break pinning. And if that happens, you're kind of out of luck. But something to keep in mind. Pinning in general is a good thing. I know OKHTTP has like APIs for it. Yeah, it is a good thing, and it's something that I support. There are less bad examples of code for it. Just because there's honestly just a lot less examples of code for it. It's sort of the same overriding the trust manager code, just there's not a lot of code out there for it.
Hi. I think in Lollipop a lot of cyber suites were dropped per default.
Mm-hmm.
I had that once. So my traffic to the server was not accepted. And people were looking at me because the Android app was not working, and iOS is still working. How can you help get the message across that, well, a lot of web servers might support still old cyber suites, and to upgrade the server, because I'm not a security expert, but when I connect to an old server, so to speak,
Right. So
people look at me. So
yeah, so dealing with old servers. So what you'd hopefully see, right, is you'll get some SSL exception back saying, like, basically no agreed ciphers or something. There is actually some information on the SSL page about kind of what to do. The unfortunate thing there is it ends up just being like, upgrade the ciphers on your server. And that's really dependent on your, like, what infrastructure are you hosting on. Like, I probably couldn't give you like specific advice unless you're doing the exact same flavor of weird Gentoo Linux shenanigans that I like to do. Don't do that. So I don't know the best thing to do for good advice on that, unfortunately. I know people are working on it, people much better at that kind of thing than I am, but I don't have any super great advice for you, unfortunately. Anybody else have questions? Otherwise, you can go get food.
Yeah.
Oh.
Hi, so you talked about basically how to trust a server.
Mm-hmm.
Is there any way to accomplish the opposite direction? How would a server
You want the server to trust the client?
trust the client?
You're in a very dangerous game if you're trying to do that. So I guess the first question is why do you want to do that?
For instance, if your web services aren't intended to be public.
So for that, client certificates. So you actually do have this two-way thing. So the server gives you a certificate, and the client can as well present itself a certificate. So for that sort of case, a common example is sort of the corporate case, right? So your IT department issues client certificates to all your devices, and then when those devices connect to your internal servers, they present that so that you can do that mutual authentication. Yeah, so that is supported by TLS, and it's just a case of getting those on the device and that kind of thing. Question over here in the corner. There's no one on this side. I can't actually see over here because the lights are right in my eyes. None of you have questions? Sweet.
Hi.
Okay.
So you mentioned about strict mode. So I just wanted to get a little bit more context on strict mode versus the TLS dependability that you're talking about, because it deals a lot with VM policies and the thread policies.
Right. So it's sort of the main difference between the two is kind of accuracy and when you should probably use them. So the strict mode detection is actually much more heavy-handed. It does IP level stuff, but it also has this issue of being false positives. And generally with strict mode stuff, you probably don't want to ship with it on like shipping out to users, because it breaks on things like HTTP proxies. The purpose of that manifest flag, on the other hand, is something that you can sort of safely ship in your actual production builds to users. So it sort of just differs on that front. As far as the policy between like thread and VM policy, You would have to ask Jeff Sharkey on the exact implementation, and he's talking later, so you should go ask him. But I believe it, actually I don't know, on the interplay between those two, between the VM and thread policy. You have to ask him. Any other questions? All right, I think there's food, and I'll be hanging out around like the office hours and stuff if you have more questions. So thank you all for coming.